Hello students, my name is Dr.Gajendra Purohit and you are watching our YouTube channel where I upload videos for engineering, mathematics and B.Sc. If you are preparing for any competitive exam that have higher mathematics, then my channel will be very helpful to you. Students, I started teaching vector calculus and here I taught you about gradient, divergent and curl. Today, I am going to tell you how we find the value of the scalar potential, because sometimes in exams, it is asked to calculate scalar potential and also the total work done with its help. So I am going to explain you all of that. What is scalar potential? If f be a conservative vector function and phi is a scalar potential of f, if f is equal to grade of phi. So here, if we have a scalar function, if we have, let's say, a phi, and if we take its gradient. So students, then here we will get a vector point function, right? And I uploaded a pretty good video on gradient. If you have not seen it yet, you can check the video on iTab where I taught how to calculate gradient and many related concepts. So you can see, students, if we have any scalar function and we take its gradient, then we get a vector point function. Now to calculate scalar potential, you have to remove this gradient and calculate this value back, right? So this concept that we discussed, this is known as scalar potential, right? There will be a vector point function given in the question and you have to remove its gradient here, which means you have to remove this and calculate the value of phi. And here, what will be this phi? This is our scalar potential. I want to tell you that whenever such question is given, we know that what we do here. We apply the del operator here. We need to remove this del operator, right? Meaning we need to do the integration. We did the differentiation and got this. Now we'll do integration. So here, this del will be removed. This means we will get the scalar potential. I'll tell you a short trick. Whenever we discuss about scalar potential or whenever we calculate the scalar potential, I want to tell you that its condition is that the curl of this should be what? The curl should be 0. Meaning whatever we have here for the f, its curl should be 0, which means it should be irrotational. Students, if this is not irrotational, then we will not be able to calculate its scalar potential, right? Because usually the concept we have here is that if we have any phi scalar potential and then we calculate its gradient, and then if we calculate the curl of that, what will be its value? It will always be 0. Okay. If this is the case, then we'll get phi scalar potential here. These types of questions comes in exams and asks to show that this is irrotational and then find the scalar potential, right? So first of all, you need to see if it is irrotational or not, and then we need to find the scalar potential. Now how do we find scalar potential? Look, this is given. I have shown the standard procedure here, but you don't need to go through all that calculation. Instead of f, just write d phi. And here, students, wherever it's I, write dx. And here, wherever it is j, write there dy. And students, wherever it is k, what will you write? Write there dz. So now here, what we have to do? Whenever we do the integration, the variables should always be separate. Okay. But here, none of the variables are separate. Here it's dx. So it should be x here. It's dy, it should be y. It's dz, so z. Now what's happening here? With dx, it will be y here, right? So we will do the integration here with y, dx is coming. And here what we will do? We will write x and dy together, right? And in the same way, the z is with dx, right? It is z dx. So what we'll do here? We will write x dz. Is that clear? Now students, we got this and we got this and we got x dz. Next is this z dy, right? Here it's z dy and here we have y dz, right? So write these together. When we will solve this, we will get d of xy. This will be d of xz. And so this one will be d of yz, right? So this value will be d phi, and when we will do its integration, so then this will be xy plus xz plus yz. So students, this will be the scalar potential. If you have any doubt that if this is the answer or not, then you don't need to do anything. If you want to check if your answer is wrong, calculate the gradient again, right? How to calculate gradient? This whole derivative with respect to x into I will be y plus z into I. This whole derivative with respect to y into j. While doing with respect to y, we'll get x plus zj. Similarly, with respect to z, we will get x plus yk. So in this way, you can check here. I have used a conservative word here. So irrotational and conservative vector are the same thing. So sometimes it is given, show that f is conservative vector or show that f is irrotational. Both are the same, right? There is no need to worry about the words at all, right? Let's move on. This is the standard procedure that I have explained. Sometimes students, the question asks about work done. let a force F act on a particle at P and let the particle be displaced along a given curve C. In space, meaning a force moved the particle from here to here. So how much work was done in moving it from here to here? We have a formula here. The formula for work that we have is force into displacement, right? So the formula for work will be F into dr from A to B. So when we calculate the value of this type of integration, what we have to do? We have to integrate the F. So what will be the question here? Let's say F is given in the question. And the question is asking to show that if it is irrotational or a conservative vector field, and then it will ask about the total work done. So if it is irrotational, then what can we do with it here? We can remove its gradient. That means we can do its integration. And if we do the integration in the way I showed you, then we will get its value and we don't have to do anything else. We will put the limit on the phi and we'll get the answer. Let's do a question to understand the concept. It will be clear. You need to understand this. Whatever phi will get, subtract the lower limit from the upper limit and you will get the answer. See the question, you'll understand. Students, this is the question. In the question, F is given and you have to prove that if this is a conservative field or a irrotational, and find its scalar potential, also the work done in moving the particle from this to this, right? So first of all, we have to see whether its curl is 0 or not, right? I also uploaded a video earlier where I taught how to calculate the curl. So you can go to the I tab and can see. Here we'll calculate del cross F. Ijk del by del x del by del y del by del z. This is i's coefficient, j's coefficient. K's coefficient, calculate this with respect to y, this with z, it will be 0. Calculate I. With respect to x, it will be 3z square here. Calculate this with respect to z. So students, we will do this with respect to z. There is a slight correction here. It's z cube. It will be 3z square. So 0. When you simplify this, its value will be 0. We got 0. This means that we will get the conservative vector field or it will be irrotational, right? What we need to do is find its scalar potential. For scalar potential, wherever there is f, put d phi there. And students, here it will be 2xy plus z cube. Wherever there is I, put dx there. And wherever there is j, put dy there. And wherever there is k, then put dz there, right? Whenever we do integration, I told you that the variables should be separate, right? If they are not separate, then we should know how to arrange them. Now, students face problem that how to arrange this here. So students, when we solve this, here the variables must be separated. If they are not separated, then I will teach you that how do we do this. So see, when there is dx and here the term is x, so here will be 2xy, dx, but y is with dx. So with dy, x will be there for sure. Write this along with that and make a bracket. Is that clear? And students, along with dx, z is there, so it is certain. Along with dz, x will also be there. See this, it's there, right? So we should write this along with this. Now we know this u into v concept. So here we are calculating differentiation with respect to what? With respect to x. Constant is y. So write here a y. Now differentiating with y, which one is constant? X square. We write it like this, right? If we write this, then differentiation is calculated with respect to what? Differentiation was calculated with respect to what? With respect to x, and constant is z cube. Now after differentiating with respect to z, which one is constant? X. On expanding by u into v, then we'll get this. Now what will you do? Do the integration. So phi is equal to x square y plus x z cube. Students, this will be the scalar potential. So we have calculated its integration, meaning we have found f dot dr, right? Now f dot dr is calculated. What do we have to do? We have to calculate the work done, and for that what do we have to do? Write f dot dr. The point given is from 1 comma minus 2 comma 1 to 3 comma 1 comma 4 is equal to, so here it will be phi. Put the value of phi x square y plus x z cube, and the point is from 1 comma minus 2 comma 1 to 3 comma 1 comma 4. So students, when we put 3 where there is x, then we will get 9 and y will be 1 here. So we'll put 3 and 4, 16, 64 and 3. So students, it will be 3 multiplied by 64, right? Minus, here we will apply the lower limit. Wherever there is x, put this, it will be minus 2. Here we'll put 1 in place of x and in place of z. So this will also be 1. When we'll solve this, so here we will write its value 9 plus, here it will be 2 and it will be 192. And minus, here students, we will get plus 1 because minus 2 plus 1 minus 1. So this will be its value. Here we will get 10. So I think it will be 202 and we will get here work done. In this way, we can easily solve this question. Let's do some more questions on this same concept. You can see I've explained its solution. Let's look at the next question. vector field is given. You have to prove that it is irrotational and find its scalar potential. So we will first calculate its curl. Ijk del by del x del by del y del by del z. I's coefficient, j's coefficient, k's coefficient is not given. It is 0. When we will calculate its curl and its determinant, what will its determinant be? It will be 0. So then we will get it as irrotational. Now we need to calculate its scalar potential. So wherever there is a, we will write phi there, we will write d phi. And this will be x square, xy square into dx plus y, x square y into, it will be dy here. It's x square with dx. So this is already separate. We will write this x square with dx because here the variable is already separate, right? In the same way, if you see, this will be y dy. But students, it is not coming here. If you see, x and y are together, right? Here we will write this together. So for sure, x is with dy. See, it's coming here. Then we will get x square y dy, right? The integration is happening directly here. And if we talk about this, what we will do? We will multiply this by 2 and we will divide it by 2. I'll multiply this by 2 and divide this by 2. You might wonder why I multiplied and divide by 2. I'll tell you the reason. Students, first of all, we will do its integration. If we do its integration, what will we get? X square dx. In the same way, it will be y dy. Now, look at this. This 1 by 2 is common, right? And students, here we will get 2xy square dx plus 2x square y dy. Let's leave this together for now, right? We will solve it later. D phi equals to, it will be x cube by 3, do its integration. This will be y square by 2 plus 1 by 2. So students, we will get, now look, when you are calculating the derivative with respect to x, then y square is constant. When we will find the derivative with y, then x square is constant. So here we will get the value, right? We'll simplify this. Then students, we will get x cube by 3 plus y square by 2 plus x square y square upon 2. So this is what we will get, scalar potential. So in this way, we can easily calculate this. If you want to check if the answer is wrong or not, find its gradient will again be the same. You can check by doing it. Moving on. So let's see the next question. Find constant A. So that A is a conservative vector field. It is asked that this A is given for what value of A? This will be conservative vector field or irrotational. So you have to find its scalar potential and also calculate the work done, right? We'll do the same thing. It will be curl V0, right? So ijk del by del x del by del y del by del z, and we have the coefficient of I, coefficient of j, coefficient of k. Let me explain this to you. I into right, calculate this with respect to y, but it is not there. Here it's z, we will do this with respect to z minus j. In the case of j, we'll do its derivative with respect to x. Students, this will be 1 minus a, z square, this is z cube. Then with respect to z, pay attention, it was z cube here. Then with respect to z, this will be negative. So negative will be positive. This will be 3z square. So what will we get here? Its value. Then write plus k. Then we will do the derivative of k with respect to x. And this will be 2x. A minus 2 minus. Right? And here, what will we do? We will do this with respect to y. Then we will get minus ax. Right? And we know that its value. What will we get? It is irrotational. So we know that this will be 0i plus 0j plus 0k. Right? And then we will equate the coefficient of all of these to 0, right? So when you equate its coefficient to 0, then it will be 1 minus a. This will be z square plus 3z square is equal to 0. Z square is 0. So this will be 1 minus a plus 3 is equal to 0. So 4 minus a equals 0. The value of a will be 4. If you want, you can also do it here. For example, if you put the value of a as 4. So 4 minus 2, this will be 4x minus 4x. This satisfies it. If we put this as 0 as well, ultimately, the value of a will be 4 only, right? Now put 4. So what we have to do is find its scalar potential. Wherever you see a, put 4 there. Finally, the value of a, the value of the a vector will be, here it is v, it doesn't matter, this v and a are the same thing, right? So make it a here, then it will be better, right? We will get here 4xy. Minus z cube into I plus, here we will put 4. Then it will be 2x square j. And students, if we put 4 here, then this will be minus 3x z square k, right? Now what will we do? We will find its scalar potential. This will be d phi, and here we will write its value as 4xy. Minus z cube, wherever there is I, we will put dx. Plus here it will be 2x square dy. And here minus 3x z square dz. So students, what value we will get? Here it's dx and here it's y besides x. So it is certain that this will be written with this. This will be 4xy. Here it will be dx plus 2x square dy. This is the value. You can see students here z is with x. Then we can be sure this x will be with dz. So keep minus s common. So here, this will be z cube dx plus 3x z square dz. Then students, what we will do here, you can see that this is the formula, right? Write d here and we are calculating derivative with respect to x here, so y is constant. And here with respect to y dy. So 2x square will be constant, u into v will be this, right? Minus with respect to x, then what is constant? Z cube. So z cube is 3z square dz, constant is x. Then just do the integration, right? If we do the integration, then phi is equal to 2x square y minus x z cube. Plus c can be written constant, usually comes after normal integration. And now find the work done. So what will be the work done here? F dot dr. And we have a point given which is from 1 comma 2 comma minus 3 2. Here it is 1 comma minus 4 comma 2, right? So students, in this what will we get here? This will be 2x square y minus xz cube into, put this point because we know that the value of f dot dr will be phi. We got phi when we did its integration, right? So we will put this point. This will be 1 comma 2 comma minus 3. And here we will write 1 comma minus 4 comma. And here what will we get? 2, right? Place the value. In place of x put 1 and in y put minus 4. Then it will be minus 8. 1 and 2. So students, this will be minus 8, right? And minus, put the second limit wherever there is x, put 1 and 2. So we'll get 4. And here we have x as 1 and this will be 3, then 9 and 27. So it will be plus 27, right? If we simplify this, students, then we will get minus 16 and minus 31. So here this will be 7, then minus, I think its value will be equal to minus 47, right? What will be the answer? 47 units. In this way, this question can be solved easily. Okay, so that was it. So students, thank you so much for watching and please comment and let me know if you like the content. If you want to see more vector calculus videos like this, you can see them here. If you are preparing for CSIR, NetGate or IIT-JAM exams and you want to improve your short tricks, you can see the entire playlist here and you can subscribe the channel. Thank you all very much. Thank you. Bye-bye.